In our first unit in physics, we're going to learn all about charts and why, as healthcare professionals, we make charts, how to use charts, and in physics, what charts are good for. So here's a chart I found on the internet. So these two charts are from a patient supposedly admitted to the ICU. They're the patients in the ICU. So notice they're taking the patient's temperature 6 times a day. So now down on the bottom, it has our time axis, and the time is measured in days. And we can see at the temperature chart of the patient in the ICU, they're taking the temperature about 6 times a day. And temperature's pretty normal. 37 degrees is normal human body temperature. And then the patient spikes a fever. And then here, the patient spikes a pretty bad fever. So notice, this is why we take patient's temperature. The patient was in the ICU, so they were also doing a white blood cell count. So they were taking a blood draw at least once a day and looking at the patient's white blood cell count. And notice the temperature data that's easy to take reflects the fact that white blood cell count, this is indicative the patient's body is trying to fight off an infection. And so we have an elevated white blood cell count. So this is the expensive test. But notice the temperature spike, the inexpensive monitoring of the patient's temperature kind of gave us warning. Oh, the patient's immune system's actually fighting off infection before the expensive white blood cell count indicated that. And we got that information. We got an indicator of that information just on monitoring the patient's temperature. All right, now here's an interesting thing in physics. Right here where we have this nice straight line, let's see, let me find a line. Look at over here on day 5. So the patient's temperature is even a little bit below normal, but here on day 5, we have this nice straight line on day 5. And notice, if you see it as a healthcare professional, you see a nice straight line in the middle of day 5, you can kind of have an idea of what's going to happen next, what's going to happen on day 6. The straight line's probably going to continue. So if you know math and you know the equation of the straight line, in the middle of day 5, you could just use the equation of a straight line and predict what the patient's temperature is for the next few hours. Right? So that's the math of charts. It allows us to predict, like if we had just finished taking the patient's temperature in the middle of day 5, we could make a prediction into the future at least a little bit. All right. So there's a couple more things about this chart that I want to say, is that look at all that the chart tells us. For instance, look at this. The patient starts out, they're monitoring the patient's temperature 6 times a day, and then we know the patient's sick. And then what happens? Look, we start taking the patient's temperature 16 times a day, because we're worried. Now, we know the patient's sick here. We need to look for any trends in the patient's temperature. And in fact, I linked this article where the article where this comes from. I'm not a healthcare professional, but according to this article, it says that ICU docs look for this steady increase in temperature because that's indicative of a more serious infection. So that's why they're taking the temperature. They go from taking the temperature 6 times a day to taking the temperature 16 times a day because they're worried. And they're actually looking for this trend because that's indicative of a more serious infection, even after the patient's temperature back here returns to normal. Look at the patient's white blood cell count. The white blood cell count is still elevated even while the patient's temperature is back to normal. And this apparently is a common thing to happen after you have this steady rise in temperature here. That indicates maybe a more serious infection that you still have to worry about after the patient's temperature it returns to normal. So you can read about this article as an aside. That part's not physics. But the math part is predicting the future based on this initial temperature. That's the physics part. All right. Now, the one thing I'm going to leave you with is it doesn't have to be a straight line for physics. So this dark line is the average growth rate of infant boy up to age 36 months, right? Not a straight line. So what we're going to end at the end of the unit is how to predict when you don't even have straight line data in physics. We'll be able to take this curvy data and make a prediction into the future about, for instance, what will be the weight of infant at age 36 months, even if we only have the infant's weight up to age 12 months. Now, and so you're going to have to use math, but how else would you do that? So this is what I want you to think about. Charts is we take charts in healthcare to monitor a patient, to maybe give us indication of what's going to happen in the future. And in physics, we're going to use those same charts to predict the future. And that's kind of exciting.